Hello everyone, as we already discussed, today we are going to study about the centroid of a T section. As you are seeing in the figure, it is a T section where the base or horizontal part is called as flange and the vertical part is called as the wave. So sometime in question it will not give you the figure of the T section, it will give the dimension of the wave and flange. Suppose here you can see the dimensions, it is 100, it is 20, this is 20 and this is 100. So what will be in questions, it will be like it will give like the flange is reference to this question, it will give like this. The flange dimension is 100 cross 20, so as you can see 100 cross 20, and the wave will be, as you can see, this is 20 and this is 100, they will give like this 20 into 100. So you have to draw like that if the question is given that flange and wave dimension. So let's start. In the previous video I told you have three important things. First of all, the thing is that we have to calculate the distance. Here I will be calculating the distance next part. So first, the most important thing is draw the reference axis. Where the reference axis will be drawn, I already told. It will be in the, where the reference axis will be drawn, it will be in the leftmost and bottommost of that particular section. It will be the leftmost and bottommost. Remember these two things. Whichever may be the section, it will be same. Where it will be the leftmost and the bottommost. So here, where is the leftmost part? This is the leftmost, and this is the bottommost. So draw two reference axes. This is one. This is one. So this is the reference, we can take it as x-axis, this is the reference y-axis. Over. So first thing is over that draw reference axis, it is done. Next thing is to calculate the symmetry of the section. Symmetric means check whether the section is symmetric or not. So how to know the section is symmetric or not? Basically in questions or in diagrams they will show you that the section is symmetric about x-axis or y-axis. Here you can see the green line is drawn, or the line is drawn between the in between the flange and wave. So the line is parallel to y-axis. So this is a symmetric line parallel to y-axis. So the section will be symmetric about. First I will show you what is symmetry. So in this figure, this is a rectangle, the length is 100. As I told you, I will not giving you the units, it will be according to the question. So just remember this. If this is 100 and this is 50, and I have drawn a vertical line here, so the section is symmetric. If the section is symmetric about this axis means this is the vertical axis. So if the section is symmetric about vertical axis, we can call it as symmetric about y-axis. So what exactly it will be? If it is symmetric about y-axis, as I told you, we basically calculate the x distance. We basically calculate the x distance from y-axis. So as the section is symmetric about y-axis, what will be? And so the length is 100. So it will divide the whole section. It will divide the length into two equal parts. That is, one part will be in the left of the vertical the symmetric axis, and another part will be in the right. So this will be equally divided. So this will be 50 and this will be 50. So what is basically, if the section is symmetric about y-axis, the length of the beam or the x-axis will be divided into two equal parts. Similarly, this is a figure. Here I have drawn the symmetric axis parallel to x-axis. So if it is parallel to x-axis, what it mean? It will divide the height. Here height is what? 50. So it will divide the height into two equal parts. So if it is 50, the upper part will be 25 and the bottom part will be 25. Like this, symmetric of a section is calculated. So you have to check whether the section is symmetric about y-axis or section is symmetric about x-axis. If the section is symmetric about y-axis, then what it tells that is x distance is calculated from y-axis. So it will, the symmetric axis will divide the whole section into equal parts. Equal parts means equally in the left hand side and in the right hand side, as you saw in this rectangle. So if the section is symmetric about y-axis, we don't have to calculate. What we don't have to calculate is that we don't have to calculate the x bar, or we can call it as xc. What is x bar and xc? X bar and xc, as I told you already, x bar and xc is the centroid about x-axis. So if the section is symmetric about y-axis, we don't have to calculate x bar or xc. It will already given in the figure. I will show you there. In this figure I will show you where it will the x bar will be. So if the section is symmetric about y-axis, we don't have to calculate the x bar or xc. Similarly, the vice versa, if the section is symmetric about next is x-axis, so we don't have to calculate y bar or yc, because we calculate the y distance from x-axis. So like this in this figure also, the section is symmetric about x-axis, so directly the section is divided into two equal parts. One part will be 25 and another part will be 25, half of the section. So these two things you remember: symmetric about y-axis, we don't have to calculate x bar; symmetric about x-axis, and we don't have to calculate y bar. So next, go to the question. What is it given? It is given that there is a vertical line. So the section is symmetric about which axis? As the line is parallel to y-axis, so the section is symmetric about y-axis. So if the section is symmetric about y-axis, what we don't have to calculate? We don't have to calculate y-axis symmetric. So we don't have to calculate x bar, but x bar will be there. Where it is? We just go to the figure. The length of the flange part is that 100 units. So we can call it as, we can take the largest length from the reference axis. Where is the largest length? Because there is two sections. The T section has two flange and wave. So what will the largest length? This is the largest length, 100, or the largest distance in x-axis. What is the largest distance is x-axis? This is 100. So we can call it as, the x bar will be, what will the x bar? 100 divided by 2. Okay, so 100 divided by 2 equals to 50. Manually we can also calculate, but for simplify, the question will given like this. So if the section is symmetric, so we don't have to calculate according to the symmetricity. Then next part, the whole T section, as I already told you, we cannot directly take the whole section. We have to simplify it by dividing into two equal two rectangles. Name the two rectangles. Here I am naming the bottom, means that this part, I'm naming it as 1 2 3 4. So I am taking what I'm taking. I'm taking 1 2 3 4 as section 1. Okay, this is section 1 and or plane 1. You can take it as a plane 1. Similarly, this is part 2. What will be the part? Suppose this is 7 8 9 10. So 7 8 9 10 is the part 2. Okay, so let's calculate. First of all, we divided into 2 sections. Next, what is that? You have to calculate the area and all these things. So for that, see, this is the section. I'll write like this: section 1. So section 1. So what will the area? First of all, I will write A1 because the formula is like this: x bar equals to A1 x1 A2 x2 A1 divided by A1 plus A2, y bar equals to A1 y1 A2 y2 divided by A1 plus A2. So what is the unknown things here? A1 A2 x1 x2 then y1 y2. So from the figure we will calculate A1 x1 y1. Similarly, for the second section, section 2, we will calculate what? A2 x2 and y2. Okay, but is the section already symmetric about? Is the section already symmetric about what? Y-axis. So already we have what? X bar. Already we have x bar. What is the formula for x bar? The formula for x bar is A1 x1 A2 x2 A1 plus A2. So we need not calculate the x1 x2, but still you write in this the answer or solution, you write the x1 and x2. So this is the A1 x1 y1 and A2 x2 y2. So what will the area of the first section? So you can see the first section is that, what is the name of the first section? It is 1 2 3 4. So what will its area? It will be 100 into 20. This is 20, this is 100. So directly it will be 100 into 20. What will the area of the second section? Similarly, this is 100, this is 20. So this will be 100 into 20. Okay. Next come the most important things: x1 and y1 and x2 y2. What will be x1 and y1 x2 y2? That will be decided from the reference axis. So first I draw the reference axis. So this will be decided, the x1 y1 and x2 y2 will be decided from the reference axis, where the distance thing will come into action. So what is the distance thing? I already told you, x distance means y axis and y distance means x axis. So from this we will go to the directly to that. So for the first section, we will be individually calculating the centroid of the particular section. So what is x1? X1 is basically the distance. What is x1? Distance of the centroid of section 1 from reference axis, or we can call it as x distance. What is x distance of the centroid of section 1 from reference axis? So here, as we are calculating this x1 or x distance, the reference axis will be what? Y, or the vertical axis. Similarly, for all, x2 will be similar, same thing. Similarly, y1 will be what? Y distance of the centroid of section 1 from reference axis. Here what will be the reference axis? As we are calculating y distance, so simple, this distance will be x, calculated from x axis. Simple. So let's go to the problem. Here, what will be the centroid of section 1, means the x-axis centroid? The length is 20. So we know that for rectangular section, the centroid is what? L by 2 and h by 2. X bar will be L by 2 and y bar will be h by 2. Okay, so here x1 is what will be its centroid? This is length is 20, so this will be 20 by 2. Okay, 20 by 2 is the centroid of that particular section. But what I told you, we have to calculate the distance from the reference axis. So what is the distance of this section from reference axis? As you can see, this is 100 and this is 20. As the section is divided symmetrically, so this is 100, this is 20. So what remain? 100 minus 20 equals to 80, and this 80 will be divided into two equal parts, so 80 by 2. So this will be what? 40. This will be 40. Okay, this is 40, this is 40, this is 40, and this is 20. So 40 plus 20 plus 40, it is 100. So it is 100. Okay, so distance of the section 1 centroid from the reference axis will be what? C. We have calculated the centroid 20 by 2, then plus what will the distance? You see here the distance, this is 20, so this is 10, this is 10, and this is 10. So this is 20 by 2, this is 20 by 2. Okay, and what will be the distance? Basically where x1 is what? From this axis to this axis. This is the centroid axis of section 1. So from this to this will be x1. So what will be the distance? What is the distance? This is 40 and this is 10. So this will be what? 50. So what will be x1? x1 equals to 20 by 2 plus 40, or we can write it as 50. Okay, very simple. Again, I am showing you that see, this is the reference to reference axis. This is 20. So this will be, what is this? Will be 20 by 2. This will be what? 20 by 2. As x bar is L by 2. So this is 20. So this will be 20 by 2. 20 by 2. What is 20 by 2? This is 10. But what we have to calculate? Distance from the reference axis. So this is 100. It is divided into two equal parts. So this is 40, this is 40, and this is 20. So what will be the distance from this to this? What will be this distance? 40 plus 10. So what will 40 plus 10 equals to 50? So I write it here. What is this? 40 plus 10 equals to 50. Next, we will go for the y1. What will be y1? The height is given. What is the height? 100. In the question, the height is given. The height is given as 100. So what will be y1? This will be height h by 2. Y bar will be h by 2. So 100 divided by 2. 100 divided by 2. Then we have to check. What we have to check? Because it will be calculated from the reference axis. So what is the distance of that section 1 y1 from reference axis? Is the section already touching the reference axis? So we don't have to add anything because it's already touching the x-axis, and basically we are calculating from this axis only. So because the section is like this, so basically we are calculating from this axis only. So this will already automatically, this will be 50 or 100 by 2. Okay, next thing is what? x2. So x2 will be what? This is 100, this is 100. So what will be x2? 100 divided by 2. Simple. 100 divided by 2. Then you have to check it is from the reference axis is not or not. This is already touching the reference axis, so this is automatically 100 by 2 or 50. Okay, so don't have to calculate or add anything to this. This is automatically 100 by 2 or 50. This is 100 by 2, 50. Okay, next thing is important. This is y2. What will be y2? What will be y2? What will be y2? This is given 100, this is 20. Okay, so y2 will be what? We will be calculating distance from this axis. Okay, so for this section height is 20, so centroid will be at what? 20 divided by 2, so it will be here 10. But this section 2 is not connected with this reference axis. Okay, so we have to calculate its distance from reference axis. So this is 100 and this is 10. So what will be distance from reference axis? 100 plus 20 by 2, or directly we can write it as 110. Simple. Again I am telling, this is section 2, this is section 2, its height is 20. So y bar will be what? 20 by 2, that is 10. But what we are calculating? We are calculating its distance from reference axis. So what is its distance from reference axis? This is 100. In question it is given, it is 100. Okay, so 100 from this to this, 100 plus 20 by 2, that is 110. So directly I am writing here, this is 110. Okay, so x1 is 20 by 2 plus 40, because x1 is not touching the reference axis, so 40 is added here plus 10, this is 150. Similarly y1 is already touching the reference axis, so directly where I am writing here 50. x2 is touching, section 2 is touching the reference axis, so x2 is equals to 50 and y2 equals to 110. Okay, next thing is that what we have to apply? We have to directly apply the formula. Formula is what? X bar is like this. So as I have already calculated a1 x1 y1, I already calculate a1 x1 y1, a2 x2 y2. So directly putting the formula, this is a formula, x bar equals to 50, y bar equals to 80. As I already told you, don't need to calculate x bar, just calculate x1 and x2, because the section is symmetric about y-axis. So no need to calculate x1, because previously also I told you x bar will be what? Largest length divided by 2 for that section. Okay, so this is 50, this is 80. Next thing is that we have to draw that line. Where will be the line? Where it will be? The section is like this. So we have calculated y bar equals to 80 and x bar equals to 50. So reference axis will be like this. So this is 50, somewhat here, because already it is given this is the symmetry axis. So it will be, because for a point two lines should intersect each other, so already one line is there, so I am not calculating x bar. Y bar is what? 80. From this this distance is already given, this is 100, so 80 will be somewhat here. Okay, this is somewhat 80. So this is the centroidal axis, this is x bar and this is y bar. Okay, like this we have to calculate the centroid of a T section from this question. So I have told you elaborately all these things. From next time I'll not I will told you about I section, L section and C section. Okay. Any doubts you can ask me in the comments. Thank you.